Alright, you are welcome again. Today I want us to talk about Newton Raphson formula. Okay? How to derive and how to use this formula. You can derive this formula using graphical method or using Taylor's series expansion. So in this lesson, we are going to use Taylor's series expansion. Okay? Now, this numerical method is talking about iterations, okay? Iterations. And in this iteration, we are going to have a starter, just like we are going to do something like a guesswork, okay? Where the root lies, we guess that the root may lie between so. So we get somewhere that is close. So we get a starter. So now, this method requires only one point to be known. So we are going to pick a point and say that this point, let's assume that is close to the root that we are looking for. Okay, so then we can call this point x naught. Now let's have the Taylor series expansion. This is it. So this is Taylor series expansion. So when you look at this very well, we are trying to find out the value of x. So but we have a point that is close to x, which is x naught. And then when you subtract this x naught from the x that we are looking for, it's going to be very small. Okay, so we assume generally that the second derivative of this x naught and all other higher derivatives are infinitesimal. Therefore, they can be neglected. What we mean is, when you subtract the x naught from x, what will remain will be very small, to tell you that the x naught that is very, very close to the x you are looking for. Okay, so now we say that the higher derivative, the second and the other higher derivatives are very small, so we can neglect it. So when we neglect it from this Taylor series, so what are we going to have? We're going to have something like this: from second derivative and higher, so are very small, we can neglect them. So this is what we have. We have f of x is equal to this. Okay, so from here we want to find the root of f of x, which is x, such that f of x will give you 0. That is the solution. The solution we are looking for is the value of x such that f of x will give you 0. F of x will be what? 0. That is the solution, or that is the root. Now from this place, now let's go. We say we are looking for the value of x such that f of x will be 0. So here we say f of x now is 0 is equal to, we have f of x naught all over 0 factorial plus f prime of x naught x minus x naught all over 1 factorial. Okay, so from here we can replace x with x1. Okay, let's assume that the x we are looking for, let's call it what? X1. So now when we write x1 in place of x, we are going to have 0 is equal to f of x naught all over 0 factorial is 1 plus f prime of x naught x1 minus x naught all over 1. 1 factorial is the same 1, right? Good. So when you simplify this further, we're going to have 0 is equal to f of x naught plus f prime of x naught and then x1 minus x naught in bracket. So this last term, which is f prime of x naught, let's use f prime of x naught to open the bracket. So when you use f prime of x naught and open the bracket, this is what you are going to have. You are going to have 0 is equal to f of x naught plus f prime of x naught multiplied by x1 minus f prime of x naught multiplied by x naught. Okay, good. Initially we are looking for the value of x, and now we replace x with x1. We are still interested in this x1, so we try to make x1 the subject. So let's pick this f prime of x naught x1 to the other side, then rearrange. This is what we are going to have. We're going to have f prime of x naught x1 is equal to f prime of x naught multiplied by x naught minus f of x naught. Okay, we want to make x1 the subject, so we divide both sides by f prime of x naught. So when you divide both sides by f prime of x naught, we are going to have x1 is equal to x naught minus f of x naught all over f prime of x naught. Hello. When we divide both sides by f prime of x naught, we are going to have that x1 is equal to x naught minus f of x naught all over f prime of x naught. Is that clear? Yes. So this will be the value for x1. Okay, and we call this the first iteration. So generally in the subscript, when you add n to it, in this x1 we are going to have xn plus 1. That is the general formula for Newton Raphson. Is going to give us xn plus 1 is equal to xn minus f of xn all over f prime of xn. Hello. So in our consequent video or lessons, we are going to see how to use this formula to solve problems. Okay, yes, now let's go.